Good morning students. We were discussing about methods of measurement of rent and we have already discussed the three methods of measurement of rent. Now we will discuss the last method of measurement of rent, that is least square method. So this least square method is a mathematical method of measurement of rent. Here what we are going to do is the time series data will be given to us. So for that time series data we are going to fit mathematical equation. So with the help of mathematical equation we are going to obtain the trend values. So the equations which are used are, first one is linear equation, then second one is quadratic equation, and third one is exponential equation. So here we are going to fit a mathematical equations for the time series data. So the mathematical equations are linear equation, quadratic equation and exponential equation. In detail we are going to discuss in further sessions. Here the process of minimization of sum of squared errors result in some equations which are called as normal equations. See, these normal equations will be used for finding the values of constants in the formula. So here what we are going to do is we are going to find the trend line with the help of mathematical equation. So the line which are drawn with the help of this least square method is called as best fitted line or a line of best fit. Line of best fit or best fitted line. So this line is drawn in such a way that following conditions are fulfilled. There are two conditions which are fulfilled in order to draw the line under least square method. So the first condition is summation of y minus y cap is equal to 0. This is the first condition, that is summation of y minus y cap is equal to 0. Here y is actual value, y cap is computed value of y. So what we are going to do is, first of all we are going to find the deviation or difference between actual value of y and computed value of y, and when you make the total of such deviation, the total will be equal to 0. So that is the first condition, that is summation of deviation of actual value of y and computed value of y is equal to 0. Now the second condition is summation of y minus y cap whole square is least. This is the second condition that has to be fulfilled. That is, as I have told you, the actual value of y and this computed value of y. So when you are going to find the deviation of actual value of y and computed value of y, then you are going to make the find the square of such deviation, and if you make the total of such square, it should be least. That is, sum of square of deviation of actual value of y and computed value of y is least. That's why it is called as least square method. So these are the two conditions which has to be fulfilled in order to draw the line under least square method. First condition is sum of deviation of actual value of y and computed value of y is equal to 0. Then the second condition is the sum of square of deviation of actual value of y and computed value of y is least. These are the two conditions which has to be fulfilled. So it is called as least square method. Now we will see what are the merits of this least square method. Then trend values can be used, can be obtained for all the time points. That means whatever time series data is given, for the time series data, for any point of time we can find out the trend values. For all the point of time we can find the trend values. As like in moving averages method, trend values will not be available for the beginning and at the end of the year. But here we can calculate the trend values for the all time periods, time points. These are the merits of this least square method. Now we will see what are the demerits of this least square method. First and foremost, the procedure of calculation is very difficult because this is mathematical method of measurement of trend of type y is equal to f of x. So what we are going to do is we are going to apply the mathematical equation. So calculation is bit difficult when compared to any other method. That is last three methods: graphical method, then semi-averages method and moving averages method is easy to calculate than this least square method. Then if fresh observations are available, the whole procedure has to be repeated once again. If any new observations are identified, then whole procedure we are going to do once again. It has to be repeated when fresh observations are available. So these are the merits and demerits of this least square method. Now we will see the first method under least square is straight line trend. First is straight line trend. So how to obtain trend values under this straight line trend? See, a straight line is represented by the equation y is equal to a plus bx. This is first equation under straight line trend method. So a straight line is represented by an equation y is equal to a plus bx. So where y is actual values whichever is given in the question. So y is actual value. For example, in question time points will be given, then sales, it may be sales or it may be production or it may be any other values which are given for certain time period. So that value we are going to take it as, consider it as y. So y is actual value. Then a and b, these two are constants. A and b are constants. Next, x is nothing but time point. X is time point. So this is a straight line equation. Straight line is represented by this equation y is equal to a plus bx. So y is actual value, a and b are constants and x is time point. So how to obtain this a and b? See, these a and b constants are obtained by normal equation. With the help of normal equation, we are going to find the values of a and b. I have told you the process of minimization of sum of squared errors result in some equations which are called as normal equation. So with the help of that normal equations, we are going to find the values of a and b. So which are the normal equations? By solving the normal equations, we can find the values of a and b. So the normal equation is summation of y is equal to na plus b summation x. This is the first equation, so this will be the second equation under straight line trend. Summation of y is equal to na plus b summation x. This is the second equation. Now next normal equation is summation of xy. Summation of xy is equal to a summation x plus b summation x square. This is the third equation under straight line trend. First equation is straight line equation, which is y is equal to a plus bx. In order to find a and b value, we are going to apply normal equation. The normal equations are summation of was plus b summation x. Summation x will be 0, so 0 into b will be 0. So from this we can find the value of a. Therefore a is equal to, we can bring this n to left hand side, it becomes summation of y divided by m. So summation of y divided by m. So we got the value of a. A is equal to summation of y divided by m. Now we will find the value of b from equation 3. From equation 3, when summation of x is 0, so when this value will be 0, a into 0 will be 0. So remaining will be summation of xy is equal to b summation x square. So summation of third equation will be summation of xy is equal to b summation x square. So from this we can find the value of b. When we take the summation x square to left hand side, it becomes divided by. So b is equal to summation of xy divided by summation of x square. So this is the value of b. This is the formula to calculate the value of a in straight line trend, and this is the formula to calculate the value of b, which are two constants. So therefore a is nothing but mean of y. A represents mean of y and b represents the rate of increase of y. Why it is mean of y is, you know, the mean formula is x bar is equal to summation of x divided by n. So here y bar is equal to summation of y divided by n. So n is nothing but number of years for which the data is given. N is number of years for which data is given. So summation of y divided by n. Therefore a is